Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today, we're starting off our biochemistry section, and we're starting off with amino acids. So amino acids are the building blocks of proteins. They contain a carboxylic acid group, amino group, a hydrogen atom, and an R group. And this is all bounded to the central alpha carbon. A key property of amino acids is chirality. A chiral molecule is one that cannot be superimposed on its mirror image. In amino acids, the alpha carbon is chiral because it's bounded to 4 different groups: the amino group, the carboxylic acid group, the hydrogen, and the variable R group. There's only one amino acid that is not chiral, and that is glycine, and this is because its R group is another hydrogen atom. So it's not bound to 4 different groups anymore. It has 2 hydrogen atoms, and that makes it achiral. In total, there are 20 common amino acids that you should know for the MCAT. These are used to build proteins, and they are known as the proteinogenic amino acids. Each has a unique R group, and by R group, I mean a side chain. This has some sort of side chain. It could be an alkyl group, a benzene ring, or some other side chain. And this side chain determines its chemical properties. So it determines if the amino acid is polar, nonpolar, acidic, or basic. Before we start, I want to give you an example of how important and medically relevant amino acids are. So sickle cell disease, it's where your red blood cells change their shape of a biconcave disc and they turn into a sickle shape. These cells break apart easily and die, and they can't carry oxygen nearly as well. Symptoms of this disease are painful episodes, anemia, and swelling of hands and feet due to low circulation. And this whole disease is caused by a single amino acid substitution, a glutamic acid to valine substitution at the 6th position of this beta-globin chain. So I'm telling you this so you can understand the importance of amino acids. Even a single amino acid change can cause such a big disease that is life-changing. Another disease you have probably heard of is cystic fibrosis that is also caused by one single mutation, and people with this mutation have to live their entire life with cystic fibrosis. I hope these examples can bring some clarity on how important amino acids are, and with that, let's get into the stereochemistry of amino acids. So amino acids are classified based on their configuration using L and D notation and RNS notation. So the L&D system is a way to describe the relative configuration of molecules, particularly sugars and amino acids, in comparison to glyceraldehyde. They use glyceraldehyde as a reference molecule as it is the simplest sugar with only one chiral carbon. To determine if an amino acid is L or D, you must get the Fischer projection of the amino acid, then you will orient it so the carboxyl group is at the top, and then you will see that the amino group can either go on the left or the right. If the amino group is on the left, then it is a L amino acid. If it's on the right, it's a D amino acid or sugar. All chiral amino acids in eukaryotes are L amino acids. The only amino acid that isn't L is glycine, and this is because this system doesn't even apply to it because it's non-chiral. Moving on to the RNS system, this is used to describe the absolute configuration at a chiral center. It's based on the Kahn-Ingold Prelog priority rules. So you assign priorities to the 4 groups around the chiral center based on atomic number. Then you look at the molecule from the angle where the lowest priority group is pointing away from you. If the order of the remaining 3 groups goes clockwise, it's R. If counterclockwise, it's S. So let's take alanine, for example, and look at its Fischer projection. Its R group is a single carbon, and we know from the priority rules that the hydrogen is always number 4. So now all we have left to rank is a methyl, which is a side chain, an hydroxyl group, and the amino group. We would rank these from highest atomic number to lowest atomic number. The highest atomic number is with the oxygen, then the nitrogen, and then the carbon. And if you draw this as a Fischer projection, you will see if you draw from oxygen to nitrogen to carbon, it will go in a counterclockwise manner. And since it's a counterclockwise manner, this is S. So since most of our amino acids are L amino acids, they are S in the RS system, except for cysteine. Cysteine is an L amino acid, but it is R due to the high atomic number of sulfur in its side chain. So if we rank cysteine substituents, they will go from sulfur to oxygen, then to nitrogen. This follows a clockwise manner and it's therefore R. Methionine also has a sulfur, but it also has an extra carbon in between it and the chiral carbon. So in ranking substituents, the sulfur is not ranked and instead the carbon is ranked because the sulfur is too far away from the chiral carbon. This is why methionine, despite having a sulfur, it is still S configuration. Understanding the chirality and classification of amino acids is very essential for predicting how they will interact in enzymes, binding pockets, and more. That's it for this episode. In the next episode, we'll talk about amino acid classifications.